Hi Engineering Science, Mr. Young here, just looking at again a new topic this time, looking at systems. This first video will go into universal systems diagram, looking more at what it is, looking at the different sections or different parts of a universal systems diagram, if I can say it, and being able to recognize where it's used, how does it interact with the products that we have in our everyday life. Okay, so if you stick around, you'll be able to find this out. Okay, thanks very much.
Okay, so looking at a bit of systems here, you've seen it just at the slide before, just the outline of what we're going to be looking at. To begin with, we're just looking at the systems of what the system looks like in any given object. So electrical objects, so you're looking at as small as a mobile phone that I'm using to record this on, or something big and complex like one of these the bridges that open to let boats through, or even as big as like a nuclear power plant station, or even a rocket going up to the moon, or space shuttle or something. So they all have the same thing in common. They all have inputs. Okay, so every system, regardless of what it is, even a domestic oven or a kettle or that, has an input, and they all have outputs as well. I say input, sometimes it's just one input, so inputs, right, or outputs, there's maybe more than one output. And then in the middle here, there's a process. Okay, the inner workings of each object, so how it sort of functions basically. So we can determine the inputs by the type of energy that's going into it, energy, or how we actually make it work. Right, i.e., is there a switch, is there a sensor, how does it get it switched on basically. And the outputs, again, we term the outputs in the way of energy again. So we can have an energy in, and it converts that energy or changes form to another energy, and some sort of output with regards to does it move, well, again, that's an energy, but looking at other things like, does it light up, does it have a motor that's spinning, etc. So some sort of maybe mechanical, or maybe some sort of like light output or something. Okay, well, this whole thing, this is the bit I've just described here: input, process. Okay, put wee arrows here. Arrows are absolutely shocking. Output. It's known as a universal systems diagram. Right. I always get asked that. You either get a question with these bits missing and say, put it in, or you'll be given this drawing and saying, well, this wee bit here, and asked, what is it? It's a universal systems diagram. It follows the exact same process for any kind of systems that are, or any object. So if you take, for example, a toaster, we'll put the toaster in the middle here. Right, what's the input? What's the output? Well, the output is going to be toasted bread, but we're not going to be worried about that too much, what the actual physical output is. So what's the output for this in terms of energy? Well, starting at the outputs first, and we'll work our way back. Heat, because it's going to heat up to cook your bread. So there's going to be some sort of heat. It's going to be some sort of sound. Okay, so there's going to be some sort of popping sound when it pops up, so that spring that's released. And that, if there's a spring or something that's released to push up the bread, that's going to be some sort of kinetic energy. So you can see even a small amount of kinetic energy there to kind of have it sort of pop the bread up. So you've got three there already. We can look at heat, sound, and kinetic. You can even say light. There might be a wee light on the actual toaster that tells you when it's on and when it's off. So it could be a light. Okay, so you can term the outputs by these ones. Now, it doesn't have to be all the ones. You might have put most of these ones down, but you can certainly see where they all come from. Inputs, you may have a switch or a dial, okay, to set the toast to whatever kind of, however, or set the sort of toasting function to however sort of brown you want your toast to be. Switch, maybe some sort of lever or something to push it down. Now these are all optional, you might only have one of these. And again, an input is going to be for energy, electricity. Usually the thing's going to be run on electricity. I don't know why I put that at the side, but you can see there. So you can see how the inputs, there may be multiple inputs and there might be multiple outputs. And to begin with, that's what we're looking for. We're just looking at what are the inputs in terms of energy and what are the outputs in terms to energy as well. And with the inputs, what kind of electrical components are we using? Switches, I would say dials and levers here as well. So we'll look at that. So if you're looking at doing this, you might want to have a wee quick look at energy just to get yourself reminded. Look at a couple of previous videos on energy to remind yourself of all the different types of energy. And you might need to dip into the introductory electrical or electronics, analog electronics video, just to have a look at, or the first task on analog electronics, to look at the different components and how to sort of recognise them, because it's different ones. I mean, there's lots of different types of switches. Okay, so a short video on that. So this is basically it for the start of universal systems diagram. It's just input, process and output. Okay.